discuss. I don't think we have much time left. Okay. Now, so this question, right? Even though technically speaking, when we say rigid tank, volume shouldn't change for the entire thing, but in this case it does change because our focus is actually on water. So it means that initially the water is this much, then the final the volume is this much. But of course, mass doesn't change. Okay, mass is something that cannot change. Okay, so here we look at what we have at the initial state first. So for part A, we need to determine the volume of the tank, right? So volume of the tank is actually quite straightforward. We know that initially the water occupies half of the tank. Final, it occupies fully. So we just need to find the volume of the initial volume of the water times 2. Then you can get the volume of the tank. Okay, so this one we ignore first. So assumptions, again, this stationary system, then this. But for now, we don't need to use this equation yet. Okay? Oh, still freeze, sorry. Okay, so anyway, here. So the isometric, isochoric closed system, we don't care first. Assumption, stationary system, delta K equals delta P equals to 0. The Q minus W equals to delta U, we don't need to use it first for now. We are just writing down. So there's no boundary work in this case because our boundary, as you can see, from the start, we set the boundary around the entire tank. So whether you remove it or not, we don't care. So meaning there's no boundary work here. So all we have is this. Okay, so like I said, part A, we don't need to use this first because we are only looking for the volume. So for part A, how do we find volume? Like I said, we can find the initial volume of the water first. So the properties that can connect to volume or related to volume would be the specific volume, right? So you look for the specific volume from the saturated water table. So now, so when you check, okay, this one needs a bit more explanation first. So if you check the table, or if you just look at this one, but again, this PV diagram will not be given to you in the exam. Most of the time, you will be asked to draw instead of having it directly. So if you check P1 equals to 200 kilopascal, T1 equals to 25 degrees Celsius, you will find that this is a compressed liquid, right? Which also makes sense. You have 200 kilopascal, which is higher than our standard atmospheric pressure, which means that the saturated temperature will be higher than 100 degrees Celsius. Usually that's how it goes. So 25 degrees Celsius, it means that this is a compressed liquid. So one tip on looking at closed system or looking at the table, right? Usually, if the question gives you both pressure and temperature, it will mean that you are either dealing with superheated vapor or compressed liquid state. Because under saturated state, these two are dependent. So there's no point giving you both. So we know that this is compressed liquid, but pressure is 200 kilopascal, which means we don't have access to the table because the table minimum is 5,000 kilopascal or 5 megapascal. So we use the value of the saturated liquid at 25 degrees Celsius. So again, we choose temperature, not the pressure. Okay. So from here, you can find VF at 25 degrees Celsius, which should be about 0.001003 meter cube per kg. So you multiply this with the mass, which is 5 kg, then this will give you approximately 0.005. I mean, you want to include the 3 also can, but approximately that. So this will be in meter cube. But of course, this is just V1, which means this is half of the volume. So the volume of the tank will be 2 times V1. So 0.01 meter cube. If you feel like changing this to liter, then you just multiply by 1,000. But don't have to run. Of course, question didn't ask for that. Okay, so I hope most of you were able to get the volume term here. Anyone have an issue trying to get this or still not very sure what I'm doing here? 3, 2, 1. Okay, then we go to part B. So part B asks for pressure, right? So P2. So now that you get this, right? So we could move on to part 2, which is to find the pressure. So for part 2, we know, for state 2, all we know is temperature is 25 degrees Celsius. So like I said, we always need to find the link or the relationship between the process. So what else do we know about state 2? Besides T equals to 25. But that is not very helpful, right? Yeah. So for state 2, we know that the temperature is 25 degrees Celsius. The other thing that we know is from the part A, yeah, we know the volume. So knowing the volume, you can find the specific volume, right, for state 2. So you can find the specific volume for the state 2. So once you found the, so you divide the whole thing by 5 kg again. So actually you go. So meaning you use V2 to divide 5 kg. 0.01 divided by 5. Okay, so this will give you 0.002 meter cube per kg. So from here, you go to 25 degrees Celsius again. You check Vf and Vg. So what do I mean by checking Vf and Vg? Let's see if I have the table. Yeah. Oops. We need to be a bit fast. Next class coming in. Okay. So we check the table, temperature table. So 25 degrees Celsius. Now, so we know that Vf is 0.001003, Vg is 43.34. The specific volume that we have is 0.02, sorry. So that 0.002 will lie between Vf and Vg, right? So if it is between Vf and Vg, what state it is in? It is a mixture, liquid vapor, right? So if it is a mixture, then we know that P2 will be P saturated at 25 degrees Celsius. So like in this case, if you go back here, it will be 3.1698. So this will be 3.1698 kilopascal. Okay, so now that we know this, so C we need to find what is the Q in. So for the Q in, you need to find U1 and then you find U2. Then you can solve Q in. Okay, so this one you can try. Q in, but answer will be 0.25 kilojoule. We have 2 more minutes, so you can take this down, or if you have any question, feel free to ask. 0.25? No, the 0.25 is the final answer. So you put in the energy balance equation that we learned, then you find U1, you find U2, sub in all the value, you will get a Q in. In this case, the only energy involved is Q in. There's no boundary work, there's no work, there's no Q out also. So you can try this on your own, see if you can get 0.25 kilojoule. So other than that, yeah, if you have no question, you are free to leave. We only have 1 more minute actually.